Hello student, I am Mrs. Neela Kotekar, Assistant Professor from PS Modern College of Engineering. Today we are going to learn an important topic from digital electronics. 1-bit memory cell. So what is 1-bit memory cell and why we need 1-bit memory cell? Basically, digital circuits are divided into two parts, combinational circuits and sequential circuits. Combinational circuits are the circuits whose output depend on the given input only. And in sequential circuit, the output depends on the given input and the previous or past stage output. For example, suppose you want to add two numbers 3 and 2. You can add directly and your output will be 5. But when you are doing counting, what we are going to do? We are adding 1 in the previous count. So that's why we call it as a sequence. In sequence, always the output depends on the previous output, or you can say previous sum. So this is the difference between the combinational circuit and the sequential circuit. So in sequential circuit, it is necessary to store the value of the previous output, and that's why we need memory. So let's see the design of the latch or 1-bit memory cell. Okay, so it is a simple circuit using two NAND gates. So these are two NAND gates, G1 and G2. So as you know that NAND gate is a universal gate and it can be used as any gate. So here we are going to use NAND gates as inverter. So this is truth table of inverter. In case of inverter, when 0 is applied, output is inverted and you will get 1. And when 1 is applied, you will get the output 0. So in this case, in 1-bit memory cell circuit, what we have done, we have cross coupled two inverters, G1 and G2. So output of this G1 is given as input to the G2 and output of G2 is given as input to the G1. This circuit is a bistable circuit. Bistable means it is having two stable state, either 0 or 1. So let's assume that as soon as you turn on the power supply, you will get 0 stable state, that is the Q is having value 0. So what will happen? This 0 is applied as an input to the G2. So output of G2 is inverted and you will get 1 here. The 1 is applied again as input of G1. So as an inverter, what will happen? Output of G1 will become 0. So 0 is again applied to the G2 and output of G2 will be 1. So you can find that when at one stage, or you can say at one clock, we are having value 0 and that value is remain 0 till the end. Or you can say that 0 is locked or latched in a 1-bit memory cell. So let's assume that instead of 0, here 1 appears. What will happen? The 1 is again given as the input of the G2 and G2 will invert it. At the output of G2, you will get 0. 0 is again applied to the input of G1 and you will get inverted output 1, and this cycle repeats and you will get value of Q1, and or you can say that 1 is locked or latched. So this is a 1-bit memory cell. It is going to store the value 0 or 1. Whichever is the value there, it is going to be stored. So what is the conclusion of this? The conclusion of this is a 1-bit memory cell. Here two outputs you can say, that Q and Q bar, and both of them are complementary. This circuit has two stable state. If the circuit is at one state, it will continue to remain in this stage only, or you can say in this state only. And if the similarly, if it is having 0 state, then it is continue to be in 0 state. So it is a 1-bit memory cell. So only thing is that in this case you can't decide which value is stored. It is 0 or 1. It is automatically stored. So you can modify this circuit, and we will see the modification in the next lecture.